Hi everyone, I thought I would start a video here on some recent updates to Binlex. So up here you can see I'm using the Python API and I'm instantiating the global configuration. I'm setting it to 16 threads. I'm reading a Mac OS sample here. I'm pulling out the ARM64 slice, which is the ARM64 image embedded in the Mako format. I'm then creating a control flow graph for it and then instantiating a disassembler using its mapped image and then passing its virtual address ranges that are executable to gate the disassembler, passing then it to the disassemble function and using entry point virtual addresses to seed the disassembler. That performs a disassembly with 16 threads using its own scheduler. And then down here, we create a YARA rule. We iterate functions to blocks. Any blocks less than 5 in size and bytes, we skip. We then go ahead and iterate instructions. We pull the semantics from each of those instructions. And then in here, we check if it is an XOR semantic. And so this means if you have an instruction or a set of instructions, any of them that form an XOR operation, this semantic will be tripped or triggered. And then we can go ahead at this point and we take the chromosome, which is the normalized pattern or normalized set of bytes, where we have a mask which pulls down the bits that are meant for memory addressing to 0, and that's what that mask does. And then that mask for the pattern for YARA here, again, it does it in the resolution of nibbles because YARA cannot wildcard in the resolution of bits. It can only do it in nibbles. So that's what it does, and that gives us our YARA patterns. And then we also add a comment here for the block address semantics. We set the condition here of at least 2 of these things, and then we print the rule out. So you can sort of think about different ways that you can leverage such a thing like this to automate some of your hunting, or perhaps you have a sample and you want to script nice rule and perhaps continue to script nice rules. Again, it's totally up to you how you want to do it. Binlex focuses on instructions and then disassembling those instructions, putting them into semantics and higher level information so we can make these types of higher level decisions off of lower level things in order to make YARA rules and do similarity. There's of course way more that you can do with it than this. I will probably do a future video showing how to do this with a local index where you can actually locally do your own vector database with local index here, even in scripting, and then populate that with vectors, either your own custom, or you could use the embeddings processor that's provided with you with Binlex in order to do so, and then query things that you believe are likely similar. So I'm going to go ahead and give this a run here. So if I run this now, it uses the full 16 threads, and look at that. We now have some patterns here, right? And we also have our comments with the relative, the associated semantics, where the binary operations are XOR operations. You could, of course, combine this with different types of heuristics, where you could look for statistically things that are likely to be cryptography functions, cryptography blocks, and you can even also break these chromosomes into fragments for rules. So like rule dot dot pattern. Let's see. I think it was fragment. Let's see here. Fragment pattern, right? So you can actually take the use that API to fragment it 2, 3, 4, 5, 6 times, totally up to you to aid you in your hunting. And if you're crazy enough, you can even perform, ignore those tree sitter errors, I don't know what's going there. You can even mutate the chromosome by using raw bytes in your own wildcard mask. So you can even get into mutations of these to find and hunt for other types of patterns as well. So now if I do this and we create our out.yara, we look at our thing here, and we can see it gives it the Binlex name and the timestamp there and provides all of that to us. So now if we do YARA on that, we can see it matches our sample. Um, so yes, there's of course more advanced things that you can do. This is literally just the beginning. Now imagine, right, if you want to generate YARA rules, everyone has their own way of doing it. Some samples are more different than others, but this should give you at least a semi-automated way to enable you to do hunting, threat hunting, detection, all kinds of interesting detection engineering opportunities here. Um, Heck, even with the vectors, you could even make your own models or AI models or things like that. So, all right, that'll be it for the tutorial today, and I hope you learned something. I'll catch you guys in the next one. See you soon. Bye.